For topic two, we're going to talk about interest that is compounded continuously. Okay, so this is kind of a different critter, so it's a different formula. Okay, so remember for regular compound interest, we have A equals P times 1 plus R over N raised to the N times T power. We no longer use that formula. That formula is when you're told the interest is compounded weekly, monthly, daily, quarterly, okay? If it says that interest is compounded continuously, it's a different situation, okay? So some banks use, let me get the yellow highlighter. So some banks use continuous compounding where the compounding periods increase infinitely. So this means interest is compounded every fraction of a second, okay? It's compounded kind of continuously, okay? Now, this does require a new formula. It also requires kind of a new number, okay? So let's talk about something that we already know that's similar in setup. Hopefully, we all are familiar with the number pi. Okay, so pi is quite literally the ratio of the circumference of a circle to its diameter. Okay, and no matter what circle, if you measure the distance around the circle and then divide it by its diameter, you're always going to get 3.14. Now, that's kind of our version of pi. Pi is truly an irrational number that never terminates, it never repeats. Okay, so there's a book that I have somewhere in my office that lists out pi to the millionth decimal place. So pi just goes on and on and on and on and on. Well, this number e is similar in that it is another irrational number. We're not going to get hung up on the details about what it is. Just know that it's another irrational number that's used in a lot of math applications. And for us, we would generally think of e as 2.71828. But luckily, there's a calculator button. Okay, so it's just another irrational number. It's similar to the idea of pi. It has nothing necessarily to do with circles, but it's similar in that it's this symbol that we use that really means this number. Okay, so E means 2.71828 approximately. Okay, just know it goes on forever. Okay, so what is the actual formula for the future value of continuously compounded interest? Well, it is as follows. And remember, I've told you this in several videos now. If you're specifically in the online class, if you don't want to print the formula sheet that's in Moodle or you don't have the capabilities to print the formula sheet that's in Moodle and you cannot come to me to get a paper copy, make sure you're keeping a list somewhere separate from your notes of all of the formulas so that you're not constantly flipping back and forth through the pages of your notes looking for formulas. Okay, so this formula is A equals P times E to the RT. So A is still future value. P is still present value. R, still your interest rate. And we would still plug it into this formula as a decimal. T is still time. And then this number E, we just have a calculator button, but it's approximately 2.71828. Okay, so it's just a number that shows up in nature. Don't get too hung up in the whys and hows of it. Just know it's a number. Okay, so let's look at an example of interest that is compounded continuously. Okay, so for example 3, it says a sum of 10,000 is invested at an annual rate of 4%. Okay, how much will be in the account in 5 years if interest is compounded first quarterly? Then we're going to compare that to compounded continuously. And then for part C, we're going to kind of compare the interest in both accounts. So which account is better for us in the end. Okay, so let's do the first part, part A. We already know how to do that. We've dealt with this stuff before. Okay, we know P is 10,000. We know R is 0.04. T is 5. N is 4 because we're looking at interest that is compounded quarterly. Okay, so let's go ahead and fill in the formula. Remember, we have A equals P times 1 plus R over N raised to the NT power. So 10,000 times 1 plus 0.04 divided by 4 raised to the 4 times 5 power. And we can go to our calculator. So, ooh, I got to change screens. All right, so we have 10,000, that's our P, times 1 plus 0.04 divided by 4 And then we're going to raise that to the 4 times 5 power. So how much would be in the account in 5 years if interest was compounded quarterly? Okay, so we would get $12,201.90. Okay, so we would get $12,201.90, assuming interest was compounded quarterly. Okay, now let's see what would happen if interest was compounded continuously. So we still have 5 years, we still have 4%, we still have $10,000. So P, still 10,000, R 0.04, T is 5. And remember, the formula here is PERT. This is the PERT formula. A equals P times E to the RT power. So we would get 10,000 times E, and we would raise it to the R times T power, so 0.04 times 5, okay? And this is not your first time seeing this number E. We talked about it in 7.6, so hopefully you're sort of familiar with where to find this on the calculator, but if not, let's go back to the calculator. So if you have a graphing calculator like this one, the first column of buttons at the very bottom is on. Go 2 above that and you have this LN button. And then notice in the upper left-hand corner of the LN button, we have E to the X. That is your E button, okay? So we want to type in P, which is 10,000. And then to get that E in there, we want to go second LN. So second LN will pop in the E and it'll automatically give you that superscript world for the RT portion of your formula. Remember, R was 0.04 and T was 5. So let's see. We get $12,214, and if we round, 3 cents. So 12 to 14.03. Let's go back to the worksheet. Okay. So A equals $12,214.03. Okay. So if interest is compounded quarterly, we get $12,201.90. If interest is compounded continuously, we get $12,214.03. Now, part C says how much interest is earned in each account, which account is better. So let's do the quarterly account. Remember, to calculate interest, we take the future value, we subtract the principal or the present value, which was 10,000. So in the account where interest was compounded quarterly, we earned $2,201.90. Now, if we look at the account where interest was compounded continuously, we had $12,214.03. We want to subtract what we initially invested, which was 10,000, and we would be left with $2,214.03. So then the question says, well, which account is better? Since we're investing money, we want the account that has the most money at the end, right? And if we look at this, continuous is slightly better. Even though there wasn't a huge difference in the accounts, the continuous account, we earned $2,214.03. The quarterly account, we earned $2,201.90. So that makes a difference of minus 2201.90. That makes a difference of $12.13. So the continuous is better by $12.13. So what that tells us, if we have the same amount of money and the same interest rate, as the compounding period increases, so does our benefit. So as long as you're investing money, and time is the same thing, the interest rate is the same thing, then the higher the compounding period, the better off you're going to be. Okay. So the more frequently interest is calculated, the better off. Okay. Now, it's not going to be like this massive savings. Again, we're going to have 12 extra dollars by doing the continuously compounded versus the quarterly. But at the end of the day, the better the higher the compounding period, the better off you're going to be interest wise in an investment, as long as all other terms are the same. Okay. Now in the next video, I think we're going to calculate present value, and then we're going to do something weird called effective annual yield. And then that'll be the end of this section.